Okay, there's a lot of people in person for the first time. Excellent. Okay, so we can start. We are very, very happy to have Bruce Schneier here. It's my great honor and pleasure to, I think it's a good addition to our seminar to have non-technical talks by celebrities. Bruce was, I think, well known to everybody. He's used to be a cryptologist. He was known as the security guru, I guess what called by the economist. He's now a thinker, author, and we had a great conversationalist, I would say. So I expect a really good talk. Please, this is a friendly talk. Feel free to ask questions, and there should be some time at the end for questions also. The title of the talk is Trust and AI. Bruce, please take it away.
Thank you. So good to see some of you. I'm Bruce Schneier. I think of myself as a security technologist, and I've been thinking a lot about security and cryptography and sort of all cybersecurity for the past 30 so years. I just wrote a book on AI and democracy that I'm not going to talk about today, and which is largely optimistic and makes the case that around the world there are some really positive uses of AI in democracy. MIT Press, non-technical audience, really meant to get people to think about the way this technology can be used for good. We're just getting a lot of this is all doom out there, and we wanted to counteract that. I am here at the Munk School for a year. I normally teach at the Harvard Kennedy School, which basically means I teach cryptography to students who deliberately did not take math as undergraduates. Because I think it's important to teach tech to policy people. And this melding of policy and tech, I think, is something that is increasingly important in our society. And some of the things I'm going to talk about here are policy things, because we as scientists need to understand policy, need to affect policy. So I'm at the Munk School. I'm happy to think and talk to anybody who's working in AI, especially the more technical people. So I've been thinking a lot about how to make these systems trustworthy. So I'm going to talk today about AI and trust, power, and especially integrity. And my plan is to make four basic arguments to you all. One, that there are two kinds of trust. There's interpersonal trust and there's social trust. And then we regularly confuse them. And what matters here is social trust, which is really about reliability and predictability in greater society. Two, that confusion will increase with artificial intelligence, and that the corporations controlling AI will use that confusion to take advantage of us. And three, that this is a security problem. It's a confidentiality problem, but it's really an integrity problem. And I think integrity is going to be the primary security challenge for AI systems of the future, and something that we as AI researchers really need to think about. And four, that this is also a regulatory problem, that fundamentally it's government's role to enable social trust, and that means it's government's role to incent trustworthy AI. So that's the outline. All right, so let's take it slower. Trust is a really complicated concept. The word is overloaded with many different meanings. There are philosophers, there are sociologists, political scientists that cover trust. They all have their own take on it. From my perspective, I want to differentiate between two kinds of trust. First is the personal and intimate trust. When we say that we trust a friend, right? It's less about their specific actions and more about them as a person. It's some general reliance they'll behave in a trustworthy manner. And that's interpersonal trust. There's also a less intimate, less personal type of trust. We might not know someone personally or know their motivations, but we can still trust their behavior. This type of trust is really more about reliability and predictability. And I call this social trust, right? The ability to trust strangers. And both of these are essential in society. And from a security perspective, this is how I think about it. We have mechanisms that induce people to behave in a trustworthy manner, both interpersonally and socially. This in turn allows others to be trusting. That in turn enables trust in society, and that in turn keeps society functioning. Right? The system isn't perfect. There are always untrustworthy people, but most of us being trustworthy most of the time is good enough. So I wrote about this in 2012 in a book called Liars and Outliers. And I wrote about four systems for enabling trust: our innate morals, concerns about our reputation, the laws we live under, and security technologies that constrain our behavior. And I wrote back in 2012 how the first two are more informal than the last two, how the last two scale better and allow for larger and more complex societies, right? They're what enable trust among strangers. What I didn't appreciate then is how different the first and last two are. That morals and reputation are person to person. They're based on human connection. Right? They underpin interpersonal trust. Laws and security technologies are systems that compel us to act trustworthy. They're the basis for social trust. So in the US, taxi driver used to be one of the country's most dangerous professions. And Uber changed that. Right? I don't know my Uber driver, but the rules and the technology let us both be confident that neither of us will cheat or attack each other. Right? The money is handled away, right, on the platform. We're both under constant surveillance, and we're both competing for star rankings. So lots of people write about the differences between living in high trust and low trust societies. But for me, the important point is that social trust scales better. Now, it used to be you needed a personal relationship with a banker to get a loan. Now it's all done algorithmically, and you have just many more options. And that scale is important. And you can ask a friend to deliver a package across town, or you can pay the post office to do the same thing. The friend, right, that's based on interpersonal trust, morals, and reputation. You know your friend, you know how reliable they are. The second is a service made possible by social trust. And to the extent that it's a reliable and predictable service, that's primarily based on laws and technologies. Both of those will get your package delivered, but only the second can become a global package delivery service, like FedEx or Purelator or UPS. So because of how large and complex society has become, we have replaced many of the rituals and behaviors of interpersonal trust with security mechanisms that enforce reliability and predictability, right? Social trust, right? That's the banker again. But because we use the same word for both, we regularly confuse them. And I think we're making a category error when we do that. And we do it all the time with governments, organizations, systems of all kinds, and especially with corporations. Right? We might think of them as friends when they're actually services. And both language and the law make this an easy category error to make. Right? We use the same grammar for people and corporations. We imagine we have a personal relationship with brands. We have corporations many of the same rights as people. So in the law, the confusion is there. And we're about to make the same category error with AI. We're going to think of them as friends when they're not. So there's a through line from governments to corporations to AI. Science fiction writer Charlie Stross calls corporations slow AI. Right? They're profit maximizing machines. The most successful ones do whatever they can to achieve their singular goal. David Runciman at Cambridge makes this point more fully. He has a book called The Handover. And in it, he describes governments, corporations, and AIs all together as superhuman machines, right, that are more powerful than their individual components. And Ted Chiang, another science fiction writer, claims that our fears of AI are basically misplaced fears of capitalism, and points out that the paperclip maximizer is every startup's business plan. And this is the story of the internet, right? Surveillance and manipulation are its business models. Products and services are deliberately made worse in the pursuit of profits. And we use all of these services as if there are agents working on our behalf, when in fact they're double agents, right? Also secretly working for their corporate owners. We trust them, but they're not trustworthy. They're not our friends, they're services. And this is going to be the same with AI. And the result will be worse, I think, for three reasons. The first is that these AI systems will be more relational. Right? We'll be conversing with them using natural language. And as such, we will naturally ascribe human-like characteristics to them. And this relational nature will make it easier for those double agents to do their work. Did your chatbot recommend a particular airline or hotel because it's the best deal for you, or because the AI company got a kickback from those companies? When you ask it to explain a political issue, did it bias that explanation towards whatever political party gave it the most money? right? Even right now in Google search, you can see which results are paid. But the conversational nature of AI is going to make it much easier to hide that hidden agenda. The second reason is power. Sometimes we have no choice but to trust someone or something because they're powerful. Right? We're forced to trust local police because they're the only law enforcement authority in town. We're forced to trust some corporations because they're monopolies, right? There aren't viable alternatives. Or maybe to be more precise, we have no choice but to entrust ourselves to them. And we're going to be in the same position with AI. In many instances, we will have no choice but to entrust ourselves to the decision making. Right? The AI will be thrust on us. The third reason to be concerned is that these AIs will be more intimate. One of the promises of generative AI is a personal digital assistant, right? Acting as an advocate to others, an assistant to you. And doing this right requires a greater intimacy than your search engine, your email provider, your cloud storage system, your phone. I'm reading papers about a potential future direct neural interface. And however you deal with it, you're going to want it with you 24/7, training on everything you do so it can be the most effective personal digital assistant. And you will default to thinking of it as a friend. You'll want to trust it. It'll converse with you in a natural language. It'll use your mannerisms and cultural references. It'll have a convincing voice, a confident tone, an authoritative manner. Right? It'll have a personality optimized to exactly what you respond to. So all this is a long-winded way of saying that we need trustworthy AI. Right? And what does that mean? I mean, AI whose behavior is understood, whose limitations are understood, whose training is understood, whose biases are understood, possibly corrected for. AIs whose values and goals are understood, that works in your interest, that won't secretly betray your trust to somebody else. An AI that's secure against hacking, right? So you know it delivers the results it promises to. Right? Remember that social trust is all about reliability and predictability, and that we would create social trust through both laws and technologies. And here I think we need both, because failures come from one of two places, right? The powerful corporations controlling the AIs, we've talked about that, and also from others manipulating the AIs, hacking them. Almost all AI systems will be used in some sort of adversarial environment. And that I mean it very broadly, that someone will have a vested interest in what the AI produces or in the data it uses. And that means it'll be hacked. And when we think about AI hacks, there are three different levels. First, right, and I mean, I guess most important, the adversary is going to manipulate the AI's output. Failing that, they're going to want to eavesdrop on the AI's output. And failing that, they're going to want to disrupt the AI's output. Right? The manipulation is the most critical. So imagine an AI as an advisor in, I don't know, an international trade negotiation, or as a political strategist, or a legal researcher. There'll be an incentive for someone to hack that AI. Maybe a criminal, maybe a government. And it doesn't matter how accurate or capable or hallucination-free the AI system is, if we can't guarantee that it hasn't been hacked, it just won't be trusted. Did the AI give a biased answer because a foreign power hacked it to serve its interest? We are already seeing Russian attacks in attempts to deliberately manipulate AI training data. Right? Did the AI give a biased answer because a criminal group is running some scam? Right? That's coming next. At the end of the day, AIs are computer programs, right? Written in software, run on hardware, attached to networks, interact with users. Everything we know about cybersecurity applies to AI systems, along with all the additional AI-specific vulnerabilities, like prompt injection, training data manipulation. But people are going to use and trust these systems, right? Even though they're not trustworthy. And trustworthy AI requires AI security, which is, as you know, a really hard technical problem because the way machine learning systems are created, right? I mean, computer security is not set up for systems that evolve. Now, we are used to the confidentiality problem. We are used to the availability problem. What's new and more important is the integrity problem that runs through the entire AI system. So let's talk about integrity and what it means. It's ensuring that no one can modify the data, right? That's a traditional angle, but it's actually much more than that. It encompasses the quality and completeness of the data and code across both time and space. Integrity means ensuring the data is correct and accurate from the point of collection through all the ways it's used, modified, and eventually deleted. So we tend not to think of it this way, but there are many primitive integrity systems in our computers, like the reboot process returns a computer to a known good state. That's an integrity system. The undo button prevents accidental data loss. It's another integrity system. Integrity is making sure the data is accurate when collected, right? That it comes from a trustworthy sensor or source. Digitally signed data preserves integrity. It's ensuring that nothing is missing, that the data doesn't change, that it moves from format to format or system to system. So anything to detect hard drive errors or file corruption or drop packets, these are all integrity systems. Checksums are an integrity system. Testing manipulating odometer readings is an integrity attack. Right? And just as in the field of cybersecurity, exposing personal data on a website is a confidentiality breach, even if we can't show that someone accessed it. Failing to guarantee the integrity of data is also a breach, even if no one can be proved to have deliberately manipulated it. Right? Integrity breaches include malicious actions and inadvertent mistakes. And most modern attacks against AI systems are integrity attacks. Like putting small stickers on road signs to fool self-driving cars is an integrity attack. Prompt injection is an integrity attack. Right? In both cases, we're using the fact that the AI model can't distinguish between legitimate data and malicious commands. So manipulation of the training data, the model, the input, the output, the feedback, these are all integrity attacks. Right? And integrity is important for these personal AI assistants, but it's arguably more important for organizations. Right? So imagine the corporate AI. Right? Integrity is critical because without it, it just doesn't work. So I think of this in terms of the evolution of the internet. So I don't know if you know this term. In computer security, we have something called the CIA triad, and that stands for confidentiality, integrity, and availability. These are the three properties that we security people are supposed to provide. So Web 1.0, 1990s, early 2000s, that was all about availability. Right? Individuals or organizations are rushing to digitize their content to create, the vast repository of human knowledge that we know today is the web, and making information available overshadowed everything else. Web 2.0, current web, emphasizes confidentiality. Right? This is the read-write web, where your private data needs to remain private. So online banking, e-commerce, social media, anywhere you're an active participant, confidentiality is paramount. Web 3.0 is the distributed, decentralized, intelligent web of tomorrow. Right? So it's peer-to-peer networking, distributed data ownership and storage, Internet of Things, AI agents. All of these require verifiable, trustworthy data and computation, require integrity. There is no real-time car-to-car communication without integrity. There is no drone coordination or smart power grid or mesh networking. And there are no useful AI agents. So I have been predicting that integrity will be the key security problem of the next decade. And it's a hard problem. Integrity means maintaining verifiable chains of trust from input to processing to output. It's both data integrity and computational integrity, authentication, secure auditing. And this is something that hasn't gotten a lot of attention and really needs some deep fundamental research. So in another context, I talked about this as a research question that rivals the internet itself. If you think about the internet, the 1970s, it was created to answer this basic question. Can we build a reliable network out of unreliable parts in an unreliable world? That's an availability question. In past decade, I asked a similar question. Can we build a secure network out of insecure parts in an insecure world? And I meant that as a question about confidentiality, about data privacy. And now I want to ask it about integrity. Can we build an integrous system out of non-integrous parts in a non-integrous world? So the answer isn't obviously yes, but it's not obviously no either. I think we actually don't know. So I have been using this as a call to research into verifiable sensors, auditable system outputs, integrity verification systems, integrity breach detection. How do we test and measure the integrity of a process? How do we recover from an integrity failure? I actually don't know the answer to any of these questions. And this is, I think, really interesting. We have a language problem. So security is to secure, availability is to available, confidentiality is to confidential, integrity is to what? Right? What is the adjective form of integrity? It's not integral, right? That's wrong. There actually is a word, and I just used it about a couple minutes ago. It's integrous. It's a word so obscure that it's not in Webster's Third Dictionary, even the unabridged version. If you go into the OED, it's there. It's marked as archaic. It has one citation from the 1500s. So I think we need to start talking about integrous system design and what it means. All right, so I want to talk about something I'm working on. Give a little example. The notion of an active wallet. Right, so right now there's a digital wallet on your phone. It's passive, right? It's a place to store images of tickets, other credentials, analog software versions of your credit cards. It's basically an analog wallet in digital form. So I'm working on a project to transform digital wallets using an internet protocol called Solid. Solid is a W3C standard for personal data stores, invented by Sir Tim Berners-Lee. This is his protocol. And the idea is basically that instead of your data being dispersed among a bunch of different systems, right, your email provider, your fitness tracker, your photo library, your credit card transactions, all of your data is stored in your wallet. Berners-Lee calls it a pod. I think of it as a wallet. And the notion is you give apps read and write permission. The interesting thing about this is that it allows for generative uses of the data. Right? The data used to be in silos, and when it's all in one place, we can imagine this new app that uses, oh, I don't know, your Fitbit data and your refrigerator data and your location data. Right? It can get access to all of that, and it could be generative things about your different pieces of data. And I like it because it distributes power to the users, right? Something not possible in present day systems. So this is an example of an AI assistant, right? It'll combine personal information about you, transactional data that you're a party to, and general information about the world. And it'll answer questions. That's easy. It'll make predictions, a little harder. Ultimately, we hope, act on your behalf, right? If agents start working. And we have demos of this in early stages, but making this work in anything resembling scale requires an extraordinary amount of trust in the system. And that's all about integrity, right? Building integrity protections into this kind of thing from the beginning. But even with technical standards, right, even with things like Solid, the market is not going to provide social trust on its own. Corporations are profit maximizers, right, at the expense of society. The lures of surveillance capitalism are just too much to resist. Corporations will build systems in their own interest and underinvest in security to protect our interests. It's what we've gotten so far, it's what we can get in the future. It is government that provides the underlying mechanisms of social trust. Think about contract law, or laws about property, laws protecting your personal safety, or any of the health and safety codes that let you board a plane, or eat at a restaurant, or buy a pharmaceutical without worry. The more you can trust that your societal interactions are reliable and predictable, the more that you can ignore the details. Right? The last time I got on an airplane, I didn't think twice about the maintenance record, or the pilot's training, or the weather, or anything. Right? That was just handled kind of by magic in the background. And government can do this with AI, right? I want to see AI transparency laws, when it's used, how it's trained, what biases and values it has. I want laws regulating AI and robotic safety. How and when are they permitted to directly affect the world? I want laws regulating their behavior as double agents. How much can they spy on us? When can they manipulate us? And minimal security standards for the computers the AIs are running on. And minimal security standards for any AI that interacts with the outside world. And this means laws that enforce all this AI security, which means two things, right? The ability to recognize when the laws are broken and penalties sufficiently large enough to incent trustworthy behavior. So these aren't new thoughts, right? Many countries are thinking about AI safety and security. The EU AI Act was passed last year. That's the first major law we have. But I think there's a critical mistake in the way the law is framed because it tries to regulate the AI and not the humans behind the AI. I mean, AIs are not people, they don't have agency. They're built by, trained by, and controlled by people, right? Mostly groups of people, mostly for-profit corporations. And I think any AI regulation should place restrictions on those people, on those corporations. Otherwise, they're making the same category error I've been talking about. At the end of the day, there's always a human responsible for whatever the AI's behavior is. And it's the human who needs to be responsible for what the AI does and what the company does, regardless of whether the action was due to an AI, a human, or a combination of them both. Right? Maybe this isn't true forever, but it's true in the near future. If you want trustworthy AI, you need trustworthy AI controllers. And we need one final thing, and that's public AI models. So these are AI systems built by academia or nonprofit groups or government itself that can and are run by individuals. So the term public model is thrown about a lot. There's a lot of people talking about it. So it's worth detailing what this means. We do not mean a corporate AI model that the public is free to use, right? We don't mean llama. We don't mean a corporate model that the government is licensed. We don't mean what OpenAI is trying to sell to Canada. It's not even an open source model that the public is free to examine and modify. And open source is a complicated term to apply to modern machine learning systems, right? Because they don't have conventional source code in the same way that regular systems do. And right now, the AI industry is trying to subvert the meaning of open source to allow for secret training data and secret mechanisms. Now, I think we need models that use private, even secret training data. I can imagine a medical model trained on everybody's personal health. But we have ways to ensuring their privacy and integrity, but that's not open source. That a public model is a model built by the public for the public. This means political accountability, not just market accountability. It means openness and transparency, paired with responsiveness to public demands. It should also be available for anyone to build on top of, so universal access, right? A foundation for a free market in AI innovations. The goal here isn't to replace corporate AI, but to be a counterbalance to corporate AI. When we started talking about this last year, when we wrote about this in our book, there were no examples, no good examples of this out there. Last month, we have seen the first real example of a public AI, and it comes out of Switzerland. The Swiss government had paired with ETH Zurich to create a public AI model. It performance is about what the best models were last year, about a year behind state of the art. Uses no no illegal copyrighted data. It uses no poorly paid global south training, right? Doesn't use human training. It is entirely open. You can see its training data. You can do it yourself, and it is available for anyone to use. A colleague of mine has put a front end on the internet, and you can use that model today. Right, my goal here again isn't to replace corporate AI, but to have a counterbalance to corporate AI. So, I mean, we can never make AI into our friends, but I think we can make them into trustworthy services, right? Into agents, not double agents. But only if government mandates it. We can put limits on surveillance capitalism, right? We can set minimal security standards. We can define and implement AI integrity, but only if government mandates it. The market is not going to do this. And I think it's well within government's power to do this. And most importantly, it's essential for government to do this. And because the point of government is to create social trust. Right, so I started this talk by explaining the importance of trust in society. Interpersonal trust doesn't scale to larger groups. And it's the impersonal kind of trust, social trust, reliability, predictability, that's what governments create. And this is going to be hard. Right? Today's governments have a lot of trouble effectively regulating slow AI, corporations. Why should we expect them to be able to regulate fast AI? But they have to. Right? We need government to constrain the behavior of corporations and the AIs they build, deploy, and control. Like governments need to enforce both predictability and reliability. So that is three work streams to facilitate trust in AI. One, AI security, as we know it traditionally, right? Making these systems secure. Two, AI integrity. In this way, I define it more broadly. And three, AI regulation, which is what's going to align everybody's incentives. And these are things we need. We need them now. We need them soon, because that's how we're going to create trust in AI that society needs as these systems become deployed and used. So that's my talk, and I'm happy at this point to take questions, comments, and conversation.
Okay, let's thank Bruce first before the questions. Yeah, I see lots of questions in the chat, so maybe
No,
the
I'll open up the
speak
chat.
up.
I've been ignoring the chat.
Well, they can speak up. I guess they're still around.
Yeah, I don't mind going to the chat. Saul says an obvious. I'm going backwards because that's the way I do it. It's difficult to oppose regulation except after very public tragedies. That's 100% true. I mean, me and computer security has been living that for decades. And, I keep thinking this breach and that breach and that breach will be the thing that will force regulation. Turns out the companies have quite a lot of political power in the US, especially. And we don't see it. Really, I'm looking to the EU. The EU is the regulatory superpower on the planet. Right? They are the political entity that is regulating the internet. GDPR, about 5 years old now, was the first comprehensive privacy regulation. And you benefit from GDPR, right? Because most companies have changed their practices globally because that is easier than figuring out who a European is. And that's an important thing about regulation, that a good regulation in a big enough market moves the planet. So GDPR, past couple of years, we've had the Digital Markets Act, the Digital Services Act, the EU AI Act, passed last year, will take effect next year. These are all major regulations that are affecting everybody. So yes. Deidre mentions air traffic controllers, certainly right. And but this is right. This is an example of government not providing the underlying services. We could just easily write about a city that has stopped inspecting restaurants, right? Because right now we just rely on the health codes, don't even think about it. Saul asks about AI versus social media. It's a lot in common. There's an essay I've just written, I'm trying to get published somewhere, on regulatory lessons that we haven't learned from social media that we can apply to AI. They're very similar. And really, if you think about it, social media has been AI for many years. Right? The algorithm, I mean, right, AI's got a lot of definitions, but these complicated systems that are feeding people what they want to see. They've been very damaging, and to me, they are AI systems. But yes, definitely a through line all through big tech, and the fact that it's the same companies that control social media want to control AI is really bad. So yes, I think there's a lot of similarities there.
So maybe we can have a couple of questions in person also. I have a question. So when you say the AI should work on your behalf. Like this is the kind of word that I was interested in. Like I don't know what that means, first of all, because it's not clear what function you're maximizing. Like does it mean like it's doing what you say, or is it doing something that is like good for you? Like
So
suicide is a good example of this. But also I want, yeah, maybe just I'll do a quick follow-up also before you get to it. It's like, so what does it mean for the AI to be acting on your behalf, and how can an AI prove to you or convince you that he's acting on your behalf, even though he's not doing what you say?
yeah, so this is interesting. I think it's really complicated. So if you read, Thinking Fast and Slow, the notion of type 1 and type 2 thinking, our intellect versus our emotion. And it's clear that we are not singular in what we want. I mean, the example would be that if you ask us intellectually, we want to eat well and diet, and when we go to the restaurant, we order the hamburger and fries. And I mean, there's lots of experiments that people order in the morning when they're not hungry for lunch 4 hours later. They order more healthy. If they get there and they're hungry, they order the unhealthy thing. The same thing at the ballot box, right? You can say that these are the types of policies you want, but you go in and you vote emotional and tribal. So, right, good question. Like, what does it mean to act on the user's behalf? We don't even know how to do that in non-AI systems. Or might it do something that the user says they don't want? As you point out, suicide prevention is a really good example, but do what is best for them. Now the question is who defines what's best, right? Suicide's easy, but there's a lot of things where that is contested. Uh, I think we have no idea. I think these are going to be fundamentally human things to discuss. What I want out of these AI systems is that whatever these decisions end up being, they're transparent and the user knows about them. Right? I might choose an AI that will, I don't know, respond to the better angels of my nature and make good assumptions about me and make choices about me that are good. I might choose an AI that is, just as emotional and irrational as I am in my most angry moments and work that way. I might choose an AI whose ethics mirrors this organization or that organization. I think right now the problem is that they're opaque. And it's less about what they do and more that we don't know what they do. But I think that
You want the
is,
AI to say that I'm maximizing your health or I'm maximizing your long-term survival or
I don't know,
something.
and maybe I
And
get a
that's why I
slider.
came up with this advice. Like, just be transparent. Like, what is it that it's trying to do here, and then try to prove it.
And maybe I get a slider because 100% maximizing health is boring. I'm not going to like that, right? That'll be no fun. So maybe I'll do 80%. And maybe after a week of that, I'll go down to 60%. And maybe I'll, visit my doctor and go up to 70%. I'm just making this up. But I think, just like in the real world, I want to give the humans agency and the ability to control this. Right? I mean, when we imagine people on a diet subscribing to a food delivery service, right? I'm going to take this out of my hands, make me healthy. And I think the systems are going to be used. I mean, people are going to have digital systems, whether they're trustworthy or not. They're gonna use OpenAI. They're gonna use somebody. And I mean, that's going to be, I just think, the worst of everything.
Yeah, there are some more chat questions. Maybe we can take a chat turn and then go back to.
All right. Saul asked about sort of the AI doomer scenario that they're just going to kill us all. So, like, why are we having this conversation? I I actually think that is largely a bullshit argument. I really do. I, there's no sign there's any, and it's a weird, it's a white male Silicon Valley libertarian argument. I mean, why is it that super intelligent AI acts just like a corporation? Like, why doesn't it solve everybody's problems? Or, I don't know, wander off proving obscure mathematical theorems? Why does it do exactly what we feel corporations do? And Ted Chiang writes about this, and he says, like, these are misplaced fears of capitalism. That's all this is. This is 100% projection. And this is
Hey,
not based
excuse me, Bruce,
on
but
science.
who said corporations are slow AI? And
That is I'm gonna blank on his name. The Scottish author, Laundry
Reynolds,
Files.
Alistair Reynolds,
No, I'm blank. I mean, it's in my talk.
Strauss, Charlie Strauss.
Charlie Strauss.
So, so do you accept that analogy? Because if you do accept that analogy, then I mean, corporations and large scale capitalism do kill us slowly.
Yeah, yeah.
For
No, no.
example,
Yeah,
energy.
it is a good analogy. I don't think capabilities there. There's a writer. Oh, his not Simon Willison. David Chapman. Really, he's an AI researcher. He has a an online booklet. It's not really that long, called Better Without AI, and it, he has a really good idea. He basically said, look, there are two poles in this AI debate. There's the AI security debate, which is they're going to kill us all, and then the AI safety debate, which is it's racist and sexist and really bad for humans right now in the moment. And he argues that there's this vast middle ground of risk that nobody's talking about. And that is that the AI will manipulate people, not even maliciously, into doing very damaging things. And there he actually points to like Facebook and TikTok, but the recommender algorithms, solely based on maximize engagement, right? Maximize time to view advertisements, that is like destroying democracy and destroying society. Those are the risks I worry about more. If there is going to be, AI dooming, none of this matters. So like, it's pointless. And that just seems like the wrong way to think. I, it, I don't see this happening in anything resembling the ways the doomers talk. I read Yudkowsky's book a few weeks ago. I'm just not impressed with the arguments.
Yeah. Hi, Bruce. First of all, congratulations on the Munk appointment. I think it's great to have you here. It's there. Second, and I was hoping to get your perspective on what's coming out of the themes of 2025 in terms of AI. One is just the explosion of open source, models out there. Like
It's crazy. There are 2 million models on Hugging Face right now. Actually, last time I checked, there are more now.
yeah, that. And the other is, and we see this in Canada, we're sort of small, but for us it's 700 million, I think, or something. And then you're seeing it around the world where they're popping up these sovereign models. We're committing billion, half a billion, etc., to building sovereign without really necessarily defining it. Do you think it's realistic that countries, governments can keep up if they have to sort of go back to scratch on it there versus the trillions that corporations are spending on
Yeah,
it?
I mean, right. So what we're learning is that yes, I mean, DeepSeek taught us that if you deny the scientists access to the best chips, guess what? They innovate. And it's just the AI companies in the US being freaking lazy because it's easier to throw money at the problem than to be smart at it. And so, I mean, I talked about the Swiss prove you can do this. They're not a big country. It's the Swiss government plus ETH Zurich. I haven't seen the dollar amount it cost, but it's not going to have been a lot. And I know that OpenAI is dangling a sovereign model in front of Canada. I'd rather Canada say, let's partner with U of T and we can make one of these. Singapore, it's not entirely a public model, but it's mostly, they have a model called Sea Lion, which is deliberately trained on Southeast Asian languages. I mean, they decided that those languages are being given short shift in the big models, and they did their own. So another example of not a big country doing this. There's a French model. I don't know the details of it. It's a few years old on how good it is. That is designed specifically for French legislatures to help them write legislation. And I think they took a public model and an open model and fine-tuned it. So we are seeing countries do this. I think it's becoming cheaper. I said 2 years ago that the price is going to come down extraordinarily because it was just scientists doing it and not engineers. And you know how when engineers get a hold of an algorithm, right? A factor of 10 improvement there, a factor of 3 improvement here. We'll throw some different kinds of hardware at it, and it's a factor of 100 improvement somewhere else. And it drops orders of magnitude fast when actual engineers who can optimize things start getting a hold of it. And that is happening.
And
So, I think this notion of paying billions for a core model, we're going to laugh at in a couple of years. It's going to be so weird. So yes, I want Canada can do this, and it's not even going to be too expensive. I think
now
it'd
I
be a
guess
great thing for Canada, or like align with Australia and New Zealand. It's like all the Five Eyes minus the U.S., like all the English language speaking countries minus the U.S. and do it.
excellent, thank you. I guess then the question is, if Canada can do it, do you think we'll get to the point where we can just do it individually and say cut everything out?
And I don't know. That is my bet. My bet is that in a few years you'll be making a model on your phone. That it'll just be much faster, much easier, and it's not going to be these big things. I mean, we'll see. I mean, we don't know if it's still asymptotic or we're hitting the top of the S curve. I think we're hitting the top of the S curve, right? There's no more data. Like more compute doesn't seem to help that much. Performance of last year's model and this year's model, I mean, it's different around the edges. And also, people don't need general purpose models. We're going to want the best travel agent model. We're going to want the best therapist model, the best attorney model, this model that does everything. I mean, that's what these companies can't seem to sell. So for those two reasons, I think we're going to see much cheaper, smaller, more individual models. Yeah, but I could be wrong about this. Like, we don't know. You know this. We don't know.
Other questions? If your question has been ignored in the chat, maybe speak up.
So Mohammed asked a good question about how this differs from product safety regulation. And you say the word agility. I think that's really important. And we have a lot of trouble in tech regulation in general. It's simply tech moves faster than law. And it's really why these companies have run circles around regulators again and again and again. I remember this with something like drones. And we were all told, don't regulate drones, it's too early, you'll disrupt the market. And then one year, everyone gets one for Christmas. And then it's too late to regulate drones, they're everywhere. So yes, it is product safety, but it's more general because we're really regulating. The regulations are more like human regulations. Right? I mean, they're opaque, just like a human brain is. We can't really go in and figure out what's going on, although I really want good research into that because you probably can go and figure out what's going on because like it's just large matrices, right? This isn't scary, it's just big. But we measure humans by their output, by what they do, by their actions, not by what neurons fire in their heads. So, I think we use the same kinds of regulatory rules that we do with humans because of that. But yeah, I mean, a lot we know. I mean, I've spent, a lot of years in security and safety regulation, and I know what works and what doesn't. So there's a lot of things we can bring to bear. It really is the political will. Right? It really is fighting the lobbying, especially in the US, by these extraordinarily wealthy companies who can, buy politicians easily. And you know that the AI industry is propping up the US economy in ways that are scary. So no one wants to touch that. Everyone, like both parties, are terrified of touching that. So it's just bad. It's just bad out there. We're going to go through another AI winter. The bubble's going to pop. Everyone's going to say this doesn't work. We're going to have to, go through it with the stuff that actually does work. We do have an AI that won a Nobel Prize, basically. Now we have an AI that is a chess grandmaster, Go grandmaster. These are really powerful things. Right? They're really good medical diagnosticians at this point. Right? These are not generative systems, they're all predictive systems. Another thing we have to deal with that everyone thinks AI equals ChatGPT. I mean, this is all the politics of this is hard. And which is why I want people on this Zoom to really think about how to engage with policy. Because otherwise we get really, really bad policy. And we have to get involved at the political level. And this is why I am teaching at a public policy school. I mean, I'm not
Mohammed,
going to
did you have
make them
anything
into
else to say?
researchers, but I want to give them good bullshit detectors.
Exactly. Thank you, Bruce. This is a great response, and this is a question I'm actively thinking about, like the question of technical regulation. But here's a problem that a lot of policy and a lot of people have told me is just like, okay, what do you want to be in the law? Like, what is that what is the mechanism? Because today you're working on this definition, like in particular, I'm working in economic fairness and privacy, two very arguably well-developed aspects of trustworthiness. But even there, we don't have like a singular definition that we can present to the lawmaker, say, this should be part of the regulation. There are attempts at it, some good, some less good, arguably. But it's just because of the agility question, like we cannot really put that into the law.
Right. What we find is what works is regulating behavior rather than mechanism. Right. So instead of like in environmental law, mandating a certain type of scrubber in your smokestack, just mandate a minimal amount of emissions, or sorry, maximal emissions. And you can do that through new technology or turning it off or whatever you want. And you do that incents an industry in solving the problem. Right, in security, I want laws that, if you expose personal data, you get fined. And you can choose, like, to protect the data with security. You can choose to delete the data. You can choose to do whatever you want. But you can't go after the result. You go after the result, and I think you incent research and development and products and services in the thing you want to happen. If you regulate the mechanism, right, the US example that always comes to mind is the US regulates the privacy of videotape rentals. And then someone invents Netflix and the law doesn't apply, right? Because it was written specific to the technology rather than general, right? We can imagine a law regulating the use of deep fakes in political advertising. I don't know if it's a good idea, but we can imagine it. But why do I care if the deep fake is made by an AI or actors on a soundstage? Right? The law should be about, right, falsehoods in political advertising. And the text shouldn't matter. And that's the way I like to think about that. The EU AI Act does that to some degree. It is worth reading that law. Right? This is the first serious attempt to regulate AI. It is law in a very large swath of the planet, and it is worth reading the details. Just so you know.
Maybe I'll ask one more question if there are not more. So what I want to know from you is like, how can mathematicians help, you think? So since this is a math seminar,
Yeah, what
would you like us to do here?
What I want out of mathematicians is formalism. Right? So I work in cryptography, and there's always been sort of two ends. I don't know if you ever go to a cryptographic conference. There's those of us who are making and breaking systems, and those of us who are doing formal methods. And like we rarely talk to each other, but occasionally something one group does is incredibly valuable. I mean, there are pieces of the formal methods in cryptography, mostly came out of MIT, that have been incredibly valuable in practical systems. So I think I need some formalism into what integrity means, how it moves, how to measure it. I don't have any theory here. So think about it. If there's anything we can do to formalize that, that will be valuable. I don't know when it'll be valuable. I don't know how. Right? I mean, we're still going to be, doing checksums, like whether or not that's formalism. But I think that would be really important. So that is what I want out of a bunch of mathematicians. Some formal thinking in what integrity means and how to define it, how to think about it.
Okay, any other questions? No, I think this has been a great discussion, and Bruce has to leave soon anyway. So thanks a lot for.
So I'm around, find me on email. I'm happy to meet and talk, and I want to hear what you people are doing. So find me.
Okay, let's thank Bruce again one more time. Thank you. Yeah, this was great.
Yeah.
This. Yeah, thank you everybody for good questions.
Thank you for organizing.
Yeah, no,
Sorry,
sorry.
what's the story with the appointment of Munk school?
Hmm?
What is the appointment of Munk school? I missed the first two.
He
There now.
is now, I mean, like, I think he has a kind of an almost an adjunct position at Munk School, so he wants to like do his own thing, so but he's here teaching courses every now and then. But so he's physically at Toronto.
Yeah. Yeah, no, I think he's actually, so was at, giving up to, Swartz, a while back. I think he's Schwartz, yeah, the Schwartz,
Short Weissman, the vector, it's the same institute in the Vector
yeah, it's
Institute.
part of their.
Oh, vectors.
Yeah. But yeah, no, I think he's legitimately concerned about the political environment in the US. Was looking for.
To get out of the US,
Get
so
out
he
of
wants
the
to
US.
be Canada. Didn't realize we were here. Thanks for coming.
Actually, so what do you working on sort of some resources for math education, not the, like the lower level stuff?
Yeah, yeah.
I think they've got some stuff that we can probably start formalizing.
That would be very good.
Yeah, just
So are you interested, you wanna be kept in some kind of mailing list or something?
Interested in what?
Just researching in mathematical AI?
Or no? There's so much going on.
Yeah.
Hi, Aaron.
Yeah, bye, everybody. Well,